absolute value equations and inequalities. So the absolute value of a number x is written just like so, and it gives the distance from x to 0 on a number line. So that is why the absolute value of a number is always positive. Right, so equations with absolute values. So for a greater than 0 and an algebraic expression x, the absolute value of x is equal to a is equivalent to x equals negative a or x equals a. Now some things to keep in mind. When a is equal to 0, then the absolute value of x equals a is equivalent to x equals 0. Now if a was less than 0, then the absolute value of x equals a has no solution. So the absolute value of something can never equal a negative number. So let's look at our first example here. Right, so we have the absolute value of 9x equals 36. What we want to do is right away rewrite this as two separate equations. We'll say that 9x equals 36, and we'll also say 9x equals negative 36. So the reason why we did this right away is because we already had the absolute value isolated all by itself. So that allows us to break it up as two separates. So now I just divide both sides by 9, and I get x equals 4, and divide both sides by 9 again, and that gives me x equals negative 4. So I end up with two solutions for this problem. Now for the next one, once again, I've got my absolute value isolated, so I can rewrite it right away as 4n minus 5 equals 6, and 4n minus 5 equals negative 6. So note that for both of these first examples, I have my absolute value set equal to positive numbers. Alright, so if it was set equal to a negative, and I had my absolute value isolated, then I couldn't go any further. It would be the empty set. No solution. Alright, so for these, I've got 4n minus 5 equals 6, and 4n minus 5 equals negative 6. So I'm going to add 5 to both sides. That gives me 4n is equal to 11, divided by 4, and that gives me n is equal to 11/4. Then I'm going to go ahead and do the next one. I'm going to add 5 to both sides. That gives me 4n is equal to negative 1, divide both sides by 4, and I get n is equal to negative 1/4. So once again, two solutions. Now for the next one, I don't have my absolute value isolated. So the first thing I need to do is I need to add 7 to both sides so that my absolute value is isolated. That gives me the absolute value of 9s plus 4 is equal to 2. So now I've got my absolute value isolated, and it's set equal to a positive number. Now I can rewrite it as 9s plus 4 equals 2, and 9s plus 4 equals negative 2. Alright, so when I do that, I'll subtract 4 from both sides. That gives me 9s equals negative 2. Divide both sides by 9, and I get s is equal to negative 2/9. I'm going to do the same thing for this next equation. Subtract 4. That gives me 9s equals negative 6. Divide both sides by 9. I get s is equal to negative 6/9, which I can simplify to negative 2/3. So I get negative 2/3 and negative 2/9 for my solution for that one. For the next one, once again, I have to isolate my absolute value sign. The first thing I need to do is subtract 8 from both sides. That gives me negative absolute value of m plus 4 is equal to negative 7. Now that negative is the same thing as saying negative 1 times the absolute value of m plus 4. Alright, so make sure it's clear that that's part of my absolute value sign. So I'm going to divide both sides by negative 1. That gives me the absolute value of m plus 4 is equal to 7. At this point, I can rewrite it as m plus 4 equals 7 and m plus 4 equals negative 7. So I subtract 4, that gives me m equals 3. Subtract 4, that gives me m equals negative 11. So I've got two solutions once again. Now for example 5, I've got an absolute value and there is a lot going inside of that absolute value. But it's isolated by itself on the left-hand side of my equation. And then it says that it's equal to a negative 2. That is a big red flag. So at this point, you should say, there is no solution. We know that there is no solution because the absolute value cannot equal a negative number. Now the last topic we're going to talk about in 1.8 is absolute value inequalities, so inequalities with absolute values. So inequalities sometimes contain absolute value notation. The following properties are used to solve them. So for a greater than 0 and an algebraic expression x, the absolute value of x is less than a is equivalent to negative a is less than x, which is less than a. The absolute value of x is greater than a is equivalent to x is less than negative a, or x is greater than a. Now note that with the less than sign you could replace it with a less than or equal to, and with the greater than sign you could replace it with a greater than or equal to, and the same thing would apply. Now for me personally, I find that the easiest way to do these problems and to make sure that I don't accidentally flip my inequality signs the wrong way is what I do is I look at my equation and whatever is here I write on this other side, but I just change the sign to make it the opposite sign, so I'll make it negative. Alright, so what that means is I've got negative 5/9 is greater than or equal to, notice that my inequality symbol is staying in the same direction, and then I've got my 5x minus 4 over 3, and then I'll put that same inequality sign and the 5/9. Now I do this mainly to make sure that I don't accidentally flip any of my inequalities so that they're facing the wrong direction, which is a very common mistake, particularly with the absolute value inequalities. Right, so at this point I'm going to separate it to two separate inequalities. So I'm going to rewrite it as negative 5/9 is greater than or equal to 5x minus 4 over 3, and 5x minus 4 over 3 is greater than or equal to 5/9. Now, once again, we don't like dealing with our fractions, so I am going to multiply the inequalities by the least common denominator. So in this case, what that means is I'm going to multiply these all by 9. And this just lets me clear my fraction. So these 9's cancel out. 3 goes into 9 3 times. 3 goes into 9 3 times. And these cancel out. So it just lets me get rid of my fractions. So I've got negative 5 is greater than or equal to 3 times 5x minus 4. And I've got 3 times 5x minus 4 is greater than or equal to 5. So at this point, I'm just going to solve each of these inequalities. So I'm going to distribute my 3. So I've got negative 5 is greater than or equal to 15x minus 12. So I'll add 12 to both sides. That gives me 7 is greater than or equal to 15x. Divide both sides by 15. And I get x is less than or equal to 7 over 15. Now I'm doing the same thing for this other one, so I distribute the 3. That gives me 15x minus 12 is greater than or equal to 5. I add 12. That gives me 15x is greater than or equal to 17. And then I divide both sides by the 15 to get x is greater than or equal to 17 over 15. For me personally, at this step, I like to go ahead and just draw a number line because it helps as far as writing it in interval notation. So I just sketch out a quick number line, and I've got 7 over 15 here, and I've got 17 over 15 here. So if I'm saying that x is greater than or equal to 17 over 15, I'm going to have a bracket, and I'm going to go in this direction to the larger numbers. If x is less than or equal to 7 over 15, I'm going to have a bracket, and I'm going to go towards the smaller numbers. So what that means as far as my interval notation is that I'm going from negative infinity to 7 over 15, bracket, union, bracket, 17 over 15 to infinity. And just so we're clear, these are brackets. Now the last one we're going to look at, go ahead and draw a line to separate it. The last one, I've got the absolute value of 2x plus 1 is less than or equal to 11. So right away, I'm going to put that negative 11 less than or equal to 2x plus 1 less than or equal to 11. Now, this one, because it had the absolute value as less than or equal to, in this case less than or equal to, I know that it's going to stay in this format. I don't need to break it up. So what I'm going to do is I'm going to subtract 1 from all of the sides. That gives me negative 12 is less than or equal to 2x, which is less than or equal to 10. And then I divide everything by 2. That gives me negative 6 is less than or equal to x, which is less than or equal to 5. Now, once again, just because I think it's a little bit helpful to see it on a number line, if you look at a number line, you've got negative 6 here, you've got 5 here, and what we're saying is that x is greater than or equal to negative 6, so it's going in this direction. Let me go ahead and put it in a different color. But that x is less than or equal to 5. So you can see here, in interval notation, my solution is negative 6 to 5 with brackets. Now, just be careful when you're doing these. Make sure that you're reading out the problem. It's very easy to get in the habit of solving a problem and forgetting to actually read through the problem. What I mean by that is, let's say you had something like the absolute value of 4x plus 1 is less than 0. Well, that's never going to happen. It's never going to be less than 0. So that would just be no solution, right? Because your absolute value cannot equal a negative number. Whereas if it said the absolute value of 4x plus 1 is greater than 0, then you can solve this one out, right? So what you would do is just solve for when it is equal to 0 and look for any value that is different from that. Now, note if it was 4x, absolute value of 4x1 is greater than or equal to 0, well, that is always. That would just be a negative infinity to infinity solution. So just make sure that you're reading it through. If I said something like the absolute value of 4x plus 1 was less than negative 2, once again, no solution. So just make sure that you're reading through the questions very carefully. Be careful not to get into the habit of just breaking it down right away without looking at what's on the other side of the equation.